All right, thanks everyone. Hello and welcome to today's webinar, Building Decarb Deep Dive, Technology, Policy, and Projects in Illinois. My name is Katie Kaluzny, Associate Director at the Illinois Green Alliance, and I'm really excited to have you all here today and host this great panel. I also want to let you know that we'll be recording today's webinar and sharing the recording in a follow-up email. You've all been muted upon entry, but please type any questions that you have into the Q&A section. And at the end of the discussion, we'll have time for some Q&A and answer the questions that came up along the way. Today's webinar was put on by the Programs Committee for the Illinois Green Alliance, a volunteer group that coordinates our education programs covering a wide range of topics. The Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. We accomplish our mission by promoting green buildings in a few key ways, educational events and panels such as these today, and engaging communities and partnering with organizations across Illinois, and advocating for new policies and legislation that support green building best practices. We're currently developing more web-based programs to engage our network. This is, I think, our 50th web-based program this year, so thank you all for joining and following us along throughout our journey this year. And our next webinar is next Wednesday, December 9th. It's called Take Action, Tips for Climate Action Ambassadors. It's at 12:30 p.m. Central Time. And also check out our events calendar for contact information for our upcoming webinars. I also want to introduce Margaret Garascia. She's the Senior Research Manager at Elevate Energy, and she's our moderator for today's session and a great volunteer on the Illinois Green Alliance Programs Committee. So thank you, Margaret, for putting together today's panel, and I'll turn it over to you to introduce the session a little bit further.
Thanks so much, Katie, and thanks everyone for joining. We're so excited to be here with such an expert panel who represent so many distinct aspects of building decarbonization. So as Katie said, I'm Margaret Garascia. I'm a senior manager at Elevate Energy, where we implement clean energy programs for people and communities who often get left behind. So these include energy efficiency programs for low-income households and affordable housing providers, dynamic electricity programs with the electric utilities in Illinois, and building electrification retrofits, which I'll talk more about in a little bit. And as many of you know, Illinois Green Alliance is shifting more proactively toward building decarb and zero carbon strategies. So today's conversation is really well timed and intended to kind of send us into the new year and beyond. And this is the first in what we hope will be a series of conversations about this topic. So please feel free to use the chat, as Katie mentioned, or email Katie or myself about topics or speakers that you'd like to see the Programs Committee consider for upcoming events. So today we're joined by three amazing speakers: Connor Jansen from Slipstream, Samantha Williams from the Natural Resources Defense Council, or NRDC, and Joseph Clair from dbHMS. Connor's going to start us off with some technical expertise on the building blocks of building decarb, the technology and equipment, and some of the considerations he faces in his implementation work. And I have a little bit more intro. Sorry, I'm going to keep talking a little bit before Connor starts. So I mentioned that I implement a building electrification pilot at Elevate, and our goal is to serve existing affordable housing. So I know that's a subset of the building stock. And we want to make sure that those folks don't get left behind as we make this transition. So I just have some numbers for folks to kind of set the context. 55% of Chicago housing units are rented, and the median household income was $55,000 in 2018. So that's all pre-pandemic figures. In Illinois, the numbers are 34% renters and $63,000 median household income. And in the US, 6% of all current homes were built in the last 10 years. So I just wanted to start the conversation with those numbers, because I think when we think about all electric new construction or an existing home that needs a new dryer, a new stove, a new heat pump, we have to understand that we can't just assume that everyone has equal access to building decarbonization. And one of my big takeaways doing electrification retrofits is that this technology is here. It's not some abstract idea of the future or for a different part of the country. We have the capability and the technology. The question is just, how do we make it work for our buildings, for our people, and the electricity grid? And that's why we're here. So I will stop talking and just give Connor a little bit of an intro. He's from Slipstream. He provides consulting, design advice, and analysis to help clients achieve exceptional performance in the built environment in the areas of energy, indoor environmental quality, and daylighting. He and the Slipstream team have been doing a lot of very exciting research and implementation related to building electrification and decarbonization. So with that, Connor, please take it away.
All right, thank you so much, Margaret. And as Margaret said, I'm with Slipstream. I'm a technical service director here, and we are a mission-driven, not-for-profit focused on energy efficiency and energy equity, really trying to help people and communities move faster and farther towards a clean energy economy. And so with that, I'm going to talk about 3 key areas around building decarbonization. And we can go to the next slide, and I'll just kind of cover just on a high level what we'll be talking about. So overview of embodied carbon, so materials in the construction of buildings. Electrification, so moving from combustion to all electric heating sources. And then finally, just touching a little bit about load shifting and timing of our electricity use and how that links back to the emissions going on at the grid. So let's get into embodied carbon. And in order to provide some context here, I thought I'd show a figure that was produced by Architecture 2030. And what this shows us is basically looking at new construction starting today and going out to the next 30 years. And the embodied carbon from the materials involved in that construction is about equal to the operational carbon, so the carbon used to heat and cool and power our buildings over those 30 years. So it's really important that we work to get this right. So on the next slide, I'll show a couple of takeaways of things that we should be looking at or considering. And first and foremost is to retrofit over new construction where possible. Then there's reducing the amount of cement we use in construction. So that's either increasing the aggregate in our concrete or just reducing the amount of concrete we use overall. Another big one is specifying steel from what's called an arc weld furnace. That burns not quite as hot as the alternative of blast furnace, and it really focuses just on processing recycled steel. And then finally, build with wood where possible. And for those of you working in the construction industry, wanting to learn more about this, I highly recommend going to the Architecture 2030 site, the materialspalette.org, and that's a really great place to get started. So we're gonna kind of move quickly through all of these items, and I'm gonna talk a little bit about the technologies for heating and cooling. And that is going to boil down to 2 systems, variable refrigerant flow systems, as well as air source heat pumps. And the main difference between variable refrigerant flow systems and the air source heat pump is that the VRF systems have multiple HVAC zones connecting back to the condenser units that are typically located outside or on the roof. Whereas the air source heat pump systems have one HVAC zone that's going to connect back to one condenser. So if you have a multifamily building, typically you're going to have the same number of condensers outside as the same number of units. Both of those systems do a really great job of providing efficient heating and cooling through various different means. So the first one we're showing here is mini split systems. Those work really well for retrofit applications as well as residential applications. So you'd have like one mini split per kind of main room in your home. Then there's the air handling unit side of things. And these air handling units can be, the large air handling units that would go on a rooftop, or they could be furnace-sized air handling units, where you basically have refrigerant coils, as you see here, replacing the furnace burner and cooling coil. And then lastly, primarily used in commercial applications are cassettes and fan coil units that would connect back to just the variable refrigerant flow system. It'd be actually kind of hard to tell the difference between those types of systems and conventional HVAC in the way that they heat and cool the space. The other important area to think about as we're trying to reduce combustion in our buildings is water heating. And the good way to do that is heat pump water heaters. And these work really well in a distributed hot water system. So that means you have one hot water heater, let's say per residential unit, or per main end use. And so here you can see we've got our furnace-sized AHU located in someone's basement, as well as a heat pump water heater right next to it. And then on the outside of the building, we have their respective condensers. Now, heat pump water heaters can have a condenser that's kind of built into that unit itself. And they could be put in like a mechanical closet or something like that. And then that mechanical closet is exhausted to make sure that you're getting adequate airflow to those heat pump water heaters. We don't necessarily recommend that solution and would say if you can put the condenser outside, that's really the best pathway forward. We've seen some of those rooms without adequate airflow really dropping down in temperature into the 40-degree mark as that heat pump pulls heat out of that air. One of the areas, though, that's still emerging with heat pump water heating technology is centralized systems. So this would be for a large multifamily building or commercial spaces where you want kind of one centralized system. Now, it is possible to have multiple heat pumps that are basically serving a large hot water tank, and then that's distributed around the entire building. I'm not aware of any of these systems that are actually operational yet in Illinois, but I'm almost certain that some of these are being designed right now to be built in the next couple of years. So when we talk about heat pumps, one of the first questions that we get is how well do they work in cold weather? And so cold climate heat pumps, which are a specific type of heat pump, can supply really efficient heating and cooling in the Illinois climate. However, we do recommend that backup heating, usually in the form of electric resistance, be provided for sub-zero condition operation, especially in retrofits. And the reason for this is under about 5 degrees Fahrenheit, the heat pump systems tend to lose some heating capacity, and they also have to operate more often in a defrost mode. Now, this doesn't really impact really well insulated and air-sealed buildings, but if you have a leaky envelope and your system doesn't have as much capacity when it's very, very cold out, that can start to become a problem. But even with including backup electric resistance heating, that annual system COP is close to about 2. So that means for every 1 unit of energy you put into that system, you get 2 units out in heating. So that's pretty good. So double the efficiency of electric resistance at the end of the day. And there's been a lot of great research going on around cold climate heat pumps. And one of the aggregators of that research, as well as developers of performance specifications, is the Northeast Energy Efficiency Partnership, NEEP. And they list manufacturers that meet their cold climate heat pump requirements. So if you're looking to specify or install cold climate heat pumps, highly recommend looking at NEEP's manufacturer list. The other question that we get pretty often is, do heat pumps cost less to operate? And the answer here is yes, but. And that but is you need to consider the monthly service charges as well as a couple other things when you're looking at the cost to operate heat pumps. And to help explain this, we're showing an energy comparison of Energy Star residential units that use gas heating compared to passive house units that use heat pump heating but had a gas connection for the domestic hot water. And those passive house units saved a lot of energy, about 36% energy savings. And that's normalized, so occupant behavior isn't necessarily included in that. But when we look at the energy cost comparison, those units were only saving about 18% on the utility bills. And that's because the monthly service charges for that gas connection were quite a large driver in the overall utility cost. So in order to kind of get that utility cost closer to the magnitude of the energy savings from from the FIAS building and those heat pumps, you really need to cut that gas connection. And another kind of example that we've looked at is as we're implementing the ComEd all electric homes pilot, we're seeing that signing up for time of use pricing is really imperative to helping get the costs of heat pump operation down below the costs of conventional heating equipment. Last question here is, do they reduce emissions? And the simple answer is yes, they do. Here we're showing a repurposed study from the state of Michigan, looking at average single family home and comparing the heating fuel against the annual pounds of CO2 emitted. And we repurposed that by replacing the Michigan emissions with average state of Illinois emissions. And if you look at comparing just the furnace to the two heat pump systems, we're already immediately saving a few percent on the annual emission rates. Now, if we include the methane leakage as part of our natural gas infrastructure, that savings increases dramatically. And so as we're thinking about the life of the heat pump equipment, we can be pretty certain that the grid is going to be getting cleaner and that these are going to continue to save on CO2 emissions. One of the other things to consider, and we'll show that on the next slide, is the sensitivity to the seasonal and time of use of emissions. So here, this is for the MISO market. So this is really the Midwest, except for Northern Illinois, and Northern Illinois is on the PJM market. But what you're seeing here are kind of two lines for each season, the average emissions as well as the marginal emissions. And what the marginal emissions represent is the last power plant that needs to turn on to meet the grid demand at that time. And you can see a lot of seasonal fluctuation as well as time of use fluctuation in the emissions factors here. And so there are a few things we can do to start thinking about how we can shift those loads around to be more efficient with the grid and the emissions at different times of the year. So for the state of Minnesota, we looked at 3 different buckets of load shifting technologies to help really optimize demand response as well as the costs going back to the customers. And those 3 buckets are event-based load shifting. So that's something like having a smart thermostat that's connected to demand response control that would get a signal back from the utility company to kind of pare down or reduce the heating and cooling that might be going on at a given time. There's regularly occurring load shifts. So that would be, for instance, an electric car that has its charging set up on a timer to only charge at night. And then finally is the bucket of energy efficiency, which is basically just lowering the whole load down through different control technologies. And so when we look at these different technologies compared to, this is statewide potential for energy savings as well as percent cost savings back to the customer, there's a few items that come right to the top and that actually have some built-in technologies that we can start using today. So at the top of this list, we've got deep envelope retrofits plus air source heat pumps. So that's going to be one of the best performing things we can do. And then also on this list, I just want to mention we have heat pump water heaters. And many of those systems come Wi-Fi enabled, so you can connect them up to the internet and really start to take advantage of time of use pricing as well as demand response. I don't believe there are any specific technologies out there right now. They are very much emerging that would connect these types of systems back to real-time carbon on the grid, but they're really close to coming out there. So I'm super excited to see how the market adapts to that. And so with that, I'm going to pass things back over to Margaret, and she can introduce our next speaker.
Thanks so much, Connor. That was great. And we had a comment about passive measures and then a question about resilience. So feel free to either go in the chat, or we can pick that back up in the Q&A. So next up, we have Samantha Williams of the Natural Resources Defense Council. She manages their Midwest team of state advocates working at the regulatory, utility, and state legislative levels to further policies that cut pollution emissions and accelerate our region's transition toward an affordable, just, clean energy economy. She and the advocacy community in Illinois have been helping to define and champion what we mean by equitable building decarb. So we're very excited to have her perspective today. Thanks, Samantha.
Thanks, Margaret. And thanks to Illinois Green Alliance for hosting this really important conversation. Looking forward to it. So as Margaret said, I'm Samantha Williams. I'm based here in Chicago with NRDC. So NRDC has been spreading the gospel on building decarbonization for several years now, but we've largely focused on California and the Northeast. And about a year ago, we started to look more seriously at the Midwest with Illinois as a priority state about how we develop a policy and advocacy framework for this region that meets the unique cold climate and purple and red state dynamics of this part of the country, that acknowledges the high hurdle we need to clear to scale up the electric appliance market in a region where most homes are heated by gas, and that focuses electrification programs and policies in a way that addresses equity and the energy burden for low-income communities. So I'll be sharing some thoughts on that today with respect to where we're headed, as well as in Illinois. As a threshold matter, I want to spend just a few minutes setting the stage for how critical the building sector is to our broader efforts to fight climate change. Next slide, please. First off, we often use this term beneficial electrification. You know, folks might have heard it before, but just in case you haven't, I'd like to define it here. This is about unlocking benefits beyond just electrification. Electrification is not going to be enough to meet both our climate goals and our equity goals as well. And so we're looking to achieve three core goals with beneficial electrification. One is making sure that it's good for customers, saving them money on their energy bills, making sure it's good for the climate and the environment, so reducing emissions overall, and supporting the electricity grid, so enabling better grid management, integrating renewables, driving down system costs, et cetera, a lot of the things that Connor was just talking about. And we'll be touching on all three of these criteria to some degree today. Next slide, please. And then just to convey the impact of the building sector on climate progress, especially here in the Midwest, I'm sure everyone's familiar with the Intergovernmental Panel on Climate Change report from 2018 that set a new benchmark for livable climate, that we need to reach net zero emissions economy-wide by 2050. And the core strategies to get there were emphasized in the IPCC report, and these are strategies that the advocacy community has been championing for a very long time now, which are energy efficiency, making sure that we transition our power generation to renewable power, and then quite literally plugging everything else into this really clean power grid, electrifying the transportation and building sectors. And to put that in perspective with the Midwest in terms of carbon, about 3/4 of the emissions in our region come from the power and transportation sectors combined, but buildings follow close after. That is the next largest single contributor of CO2 emissions. And in Illinois, it accounts for 18% of the state's overall CO2 emissions is direct on-site fossil fuel consumption in buildings. And so the next slide, just to drive home a little bit deeper the importance of building electrification advocacy, specifically in the Midwest here, this is a slide showing that 10 states contribute to over half of these direct greenhouse gas emissions from the building sector, with 4 of those states right here in the Midwest, and Illinois is number 3, only after California and New York. So as we transition the building sector in the Midwest and in Illinois, we will have a really big outsized impact nationally. Next slide, please. This is just one more piece here to drive home the scale of the challenge, that here in the Midwest, we do have a majority of our home heating reliant on fossil fuels, on gas, as well as on propane. So we do have a ways to go. We are in the Midwest more reliant on gas for home heating than the national average. And this slide breaks down the different fuel types for residential home heating. And so the good news, as Connor was talking about, is that it is beneficial from a climate perspective today in Illinois to switch to electric appliances. In addition to some of the work that Slipstream has done, Elevate and RMI released an analysis in September confirming this benefit for Illinois, that if you electrify space and water heating and cooling in single-family homes, you do reduce CO2 emissions starting today and over the lifetime of those appliances. Next slide, please. Getting into some of the policy options here that we tend to recommend to further this space in the Midwest and elsewhere. This is a huge undertaking to transition our building stock by 2050 and get to net zero emissions and almost entirely all electric appliances in our homes and in our businesses. We're going to need a multifaceted and strategic portfolio of policies to get that done. It's going to require a combination of carrots and sticks to scale the technology, to develop new policies and finance retrofits, and eventually reach tens of millions of households and businesses across the Midwest. But it's important to acknowledge that this transition is going to take time, but we do need to start setting those foundational policies right now. And that's going to be very key. So this slide lays out an initial framework for how we are thinking about this in the advocacy community. So number one, and these are 4 buckets of overall policy goals that we are pursuing, is stop digging the hole. So in terms of new buildings, again, transitioning the building stock is going to be a big challenge. It's going to take decades. And with each new home that is built, we are locking in fossil use into homes for several decades. And so we only have so many opportunities to come in and make these changes. So with new construction, a critical first policy step in the transition to all electric homes is stretch or reach codes. And those are local building energy codes that reach beyond the state minimum requirements for energy use in building design and construction. And reach codes have historically been focused on energy efficiency, but there's a growing movement to push them into the decarbonization and electrification space as well. And we've seen that now happen in a handful of states, largely out west. In Illinois, we do have an opportunity with stretch codes. In the residential code, there's a pretty clear home rule preemption clause that exists right now that a city can only go more stringent than the max energy code that the state has adopted if it's, and bear with me here on this one, if it adopted the 2006 IECC prior to 2009, unless you're in Chicago. So a lot of cities then are probably stuck under this preemption clause in Illinois, and we actually have legislation proposed right now with the Clean Jobs Coalition. It's called the Clean Energy Jobs Act, that would provide some easing of this preemption, and it would require the Illinois Capital Development Board to set a model stretch code that would meet certain benchmarks every 3 years, and that would give municipalities the option to adopt that and go further than the most recently adopted code. And then also from a cost effectiveness perspective, Connor touched on this a little bit, but in terms of new home construction, electrification is cost effective right now compared with the lifetime of appliances when compared with gas and with propane, especially when you're considering the avoided costs of infrastructure and the gas hookup, et cetera. We have some preliminary analysis for Illinois that's not released yet, but that does confirm this for single family and multifamily buildings as well. So secondly, on the policy framework is for existing buildings, developing the market and transforming this market. In these early stages, it's really critical that we start to get this technology out there, build demand and bring costs down, not dissimilar to what the rooftop solar industry did over the last decade and has been really successful at doing. So there's many elements to developing the market for electric technologies, but one of them, in our view, the biggest opportunity is just to get demonstration projects out there. We need to get these new technologies into people's homes, build awareness and buy-in, and demonstrate that they can improve people's comfort in their homes, they can cut energy use and energy bills and improve health outcomes, and also build awareness amongst builders and contractors and those who maintain appliances, et cetera. And as Margaret mentioned at the top of this webinar, we really do want to challenge the community in Illinois and in the rest of the region to focus on underserved communities first in the low-income and affordable multifamily housing sector. There is a concern that as electric appliances pick up steam, you will have people exiting the system who have the means to do so, and that will leave the most vulnerable customers behind with increasingly higher bills. And so we really do want to make sure that low-income residents are prioritized early for electrification. few more things to note with respect to existing buildings. A few more trends is building performance standards are starting to become more prevalent. There's about 3 or 4 of these that have been adopted in cities across the US to date for existing buildings. One was just enacted in St. Louis by ordinance a few months ago. It applies to buildings over 50,000 square feet. And so this sets just a minimum performance for energy efficiency for buildings of a certain size. We also see energy efficiency programs as a great opportunity for retrofitting existing buildings and pairing the electric technologies and appliances with efficiency envelope measures to make sure that those cold climate heat pumps really function well. And in Illinois, we have a great example of that. In ComEd territory, we have a pilot where ComEd is replacing electric resistance heat in affordable multifamily housing with heat pumps. And we expect to see that transitioning to a full-blown program in the next set of portfolio plans. Number 3 is, in terms of the policy framework, is removing regulatory barriers to electrification and making sure that this stuff can get into the market. These barriers can exist with respect to efficiency statutes. Some states have fuel switching barriers. In Illinois, there's no explicit barrier, but there is in other states. We also have opportunities in efficiency statutes as well to credit gas savings towards the kilowatt hour requirements under an efficiency standard. We have that in Illinois. And if new legislation that's currently drafted passes, we will see that expanded in the coming years. And then, as Connor noted, rate design is another really important regulatory either barrier or opportunity for electrification. Getting rates right will be key to realizing customer savings and grid benefits. We see time of use rates as a really big opportunity, real-time pricing. All these electric appliances are going to be key to flexibility on the demand side. They can be controlled in many instances and help balance the grid and save customers money, but also integrate renewables as well. And then finally on this slide, planning for an equitable and just transition for the gas system in our states. This is a much longer term conversation for Illinois and parts of the Midwest, but it is an important issue to keep in mind. And we need to think about the workforce, particularly the pipe fitters and communities that have relied on gas and make sure that that transition is just. But I do want to mention that there's this really great Rewiring America report that was released earlier this year that demonstrates the huge economic and workforce juggernaut that is electrification and lays out some of those opportunities that we should be considering longer term. And in the near term, in terms of the transition, looking at places where new pipeline is going to be extended or where pipeline is being replaced and trying to manage that and looking at electrification alternatives is something that NRDC and others are doing. Next slide, please. So just a few more quick things to note, and then I'll hand this off to the next panelist. Margaret mentioned the large proportion of renters in Chicago, large proportion of low-income residents as well. It's really important that we lead with equity in the Midwest as we talk about electrification. There's many reasons for this, but there are 3 that I'm going to highlight here. One of them is the energy burden and affordability. As Connor mentioned, getting off that gas connection is going to be key to address the energy burden, and particularly in places like in Chicago, where you have People's Gas and their pipeline replacement program projecting to double fixed costs on people's bills in the coming years from a current $40 per month up to $80 and even higher. These are serious affordability issues for low-income residents, which can lead to a spiral of gas costs. That's the graphic here on the right side of the slide, that, as I mentioned earlier, as the system gets more expensive, people with means leave the system. You do have vulnerable communities and low-income customers at risk of being stranded on a gas system that has increasingly higher costs and really having to shoulder those costs. We really want to make sure that we are prioritizing them for electrification programs and making sure that they have a seat at the table in designing those programs as well. And on the slide here, there's a really great Greenlining Institute report about equitable building electrification that lays out how to engage communities and how to think about this issue in a more just way. And then finally, last but not least, on the equity side is indoor air quality, that eliminating the emissions from burning fossil fuels inside the home actually provides some major health benefits, particularly from stoves. Gas stoves release carbon monoxide, They release NOx and other harmful pollutants. And there were a few reports released this year on the issue that I linked to here in the slide from Sierra Club with UCLA and Rocky Mountain Institute if you want to take a closer look. Next slide, please. This is just a graphic representation of some of the outdoor and indoor air quality issues with respect to combustion of fossil fuel in people's homes. And then on to the final slide here. Right, so I wanted just to very quickly touch on low carbon gas alternatives. This is a bit of a detour, but it's an important addendum to the electrification policy discussion because we hear the gas industry talking a lot about low carbon gas. Why can't we just put that low carbon gas into the distribution system and avoid, transitioning all of these building end uses to electrification? And the answer is it's just not feasible, unfortunately. It's not likely to be scalable. It's not likely to be cost effective. And I provided some links here in this slide. I'm not going to go through this in much detail, but there is, with respect to biogas and synthetic gas, there's limited availability, not enough to cover our home heating needs. And this is supported by an American Gas Foundation report released last year. NRDC released a similar report that examined some of those numbers as well that I encourage you to take a look at. And then there's really high cost to scale these solutions as well. We're talking anywhere from 3 to 15 times the current price for fossil gas. And then finally, we're still talking about having indoor air quality concerns. With biogas and synthetic gas, they continue to use methane when combusted in homes, that it still releases all the harmful air pollutants we were just talking about. And then finally, a reminder that we need to get the entire housing stock as close to zero emissions as possible by 2050. And heat pumps are here today. They're the most feasible, the most cost-effective way to get there. And so we recommend reserving these other solutions like biogas, like synthetic gas, like green hydrogen, for the harder to electrify end uses that are going to be a lot peskier, like heavy industry and long distance transportation, et cetera. So thank you very much, and I'll pass it back to you, Margaret.
Thanks so much. That was great. We actually, perfect timing because we had a question come in the chat about that last topic, renewable natural gas. So thanks for touching on that one. And we also had a question about education that a city can provide, like what can people do, which is a perfect segue to our next panelist, Joseph Clair. So Joe is practice lead at Database Plus, which is a studio of dbHMS. It's a research-driven, human-centered design support studio helping owners, developers, architects, planners, and other stakeholders deliver ambitious vision with positive human outcomes. And he has been an integral advisor on the mechanical and electrical engineering for Elevate's own electrification retrofits. So super glad to have him here today to talk about this. So what can we all do when we think about these topics in our work and in our lives? So thanks, Joe. Take it away.
Great. Thanks so much, Margaret. And thanks to Connor and Samantha. That was a great, very detailed explanation, as quick as we could under the time constraints. So there's a lot of information flowing at everyone. And wanted to kind of close out the presentation piece of this by talking a little bit about what you can do with this information and what are some of the obstacles you're likely to encounter and kind of how to overcome them in this transition period. So I've gone to the next slide. I'm going to talk a little bit about the personal side because I have taken on this electrification project in my house. I'm lucky both to myself to be an engineer, but also to be married to an electrical engineer. So got a little bit of in-house expertise and talk a little bit about that piece of it, but also on the professional side. As Margaret mentioned, we are working, really thrilled to work with the Elevate team on the electrification of low-income housing. And we are working on the C40 project, which is pictured there. That POA is doing on the west side of the Garfield Green project with Perkins and Will and Skender, that is going for full electrification as part of the decarbonization goals of the C40 projects. So I want to talk a little bit about both of those. And if we first go to the next slide and talk about the personal side, I think there are a couple of key things that you need to think about as you're doing this and kind of bringing this home into your own personal situation. One is looking at the idea of planned obsolescence. So it would be great, the idea of turning over every single building that has natural gas in it to heat pumps or to electric technologies, and really doing that immediately is great, but there are really significant challenges to that, both in terms of the availability of product, the stress on the grid, which I'll talk a little bit about later about how that's going, So you want to kind of look at this in terms of when, kind of do a stock of when are the various gas consuming appliances in your home going to be obsolete? When are they going to reach that standpoint? Or obsolete, or when are they going to need to be replaced? And so you kind of map that out, take a look at what's what from your dryer, your stove, your heating system, and then go out to in. If you've got money to invest and if you get, can tap into some of the incentive programs, look at insulating first. I think both Connor and Samantha mentioned the idea of, when you're going to invest in these new technologies, you want to make sure that the load in your house is as low as possible. And so, this is a strategy that the Board of Ed has used for decades in terms of investments. It's a really smart one. Take your first money and insulate the attic and insulate your walls. If you can, and if you have the ability to, replace those windows, those are all going to have positive benefits for both carbon and for the building itself. And then you want to be strategic about your choices. I'm going to talk in a second about one of the obstacles is the electric capacity in the home. And you want to make sure you're buying that and making those upgrades when it makes sense. So if you're already going to do a kitchen renovation project, obviously that's a great time to do a stove, but it's also probably a great time to look at upgrading any sort of electrical infrastructure. And especially for those of us who have lived in houses that are very old, that sometimes cloth wiring can be in the house, and it could be old circuit breaker panels. Those are things that are usually desperately in need of upgrade anyway. So when you're upgrading them, really being strategic about planning that all out. And I can't help but drive home the point about planning. A lot of times, and I'm certainly one of them, even being an engineer, we end up replacing the water heater when it breaks. So we end up replacing the furnace when it breaks. And then invariably it breaks in the middle of January when it's 40% more expensive and we can't be without it. And so we're not going to make the decision to go to electrification at that point. So you want to get ahead of that and really take a little bit of time and do a little bit of working on that element. But if we go on to the next slide, we look at the professional side. And this is in the new construction environment, this is pretty easy. But even in the renovation environment, we tend to work best in mindsets. There's an old joke about engineers. Why did the engineer cross the road? Because he looked in his file and that's what he did at this time last year. We like that kind of certainty. But we can also build that certainty into our practice by, in this case, defaulting to electrons. Just start with every project going electrified, and only work off that when you run into situations where it is just either not logistically feasible or cost feasible, but really make the base case the electrified version. And then lift up practitioners, work with architects, work with contractors, work with developers who really understand the benefits of electrification and how to make it work. A lot of times, professionals that are really good at this end up spending a lot of our time trying to educate and work and bring people up, and that's great. But in a lot of cases, it's really much easier just to work with people who get it already. And so that it kind of limits that piece of it, so we're all working in the same path. Future-proofing is key. So there are going to be occasions where it just cannot work. And I will give an example. We just worked on a dormitory project. We electrified the HVAC system. We electrified a couple other systems, but we just couldn't convince to electrify the hot water system. But we were able to locate the hot water system and provide the capacity for electricity in the building so that in 10 to 15 years when the water heaters do go out, that it could be switched relatively easily over to heat pump technology. So making sure that that is part of the consideration, even if it doesn't end up that way. And kind of addressing one of the questions that came up in the chat earlier about, how do we address resilience? Well, that's where the idea of nanogrids and microgrids comes in. And really on the building side, the nanogrid side is really building in this thought into the electricity distribution of self-resiliency. So building in, whether it's solar plus battery or whether it's on-site battery storage, whether it's internal smart grid, whether it's internal DC grid, there are a whole bunch of different strategies that are out there for making sure that building systems serve the building even under difficult conditions or under loss of power conditions external to the building. But there are other elements of integrative design that play into this as well. Designing buildings with strong thermal envelopes so that if there is a heat loss in the building or electricity loss in the building, that the building can go for 8, 12, in some cases 72 to 96 hours without the heat being on and still maintain safe, comfortable conditions inside. We have the ability to do that now, and we have the ability to do that at cost. So building that in is of key importance. So if we go on to the next slide, we look at some of the obstacles that come into play when we start talking about delivering electrified buildings. And some of these are really specific to retrofit scenarios. Some of them do come into play when you talk about new design. But this one specifically is on a retrofit scenario. And it's something that we're learning as we're working through the project with Elevate Energy. And we knew going in, but now we're being able to start doing some quantification. You know, we look at a load center being the typical panel for an apartment or for a house. You know, that's the main electrical panel that you're going to have that all these different devices are going to connect into. And in most existing buildings, there is no, you know, the stove has a very minimal, you know, circuit plug. It plugs into a standard outlet, so it has a very minimal draw. And your dryer has, again, a minimal draw for the rotating tumbler, but it doesn't have all the things you need for heat. And so when you start adding these things in, you go up above what a typical load center will need. So you will need, for a fully electrified building, somewhere between, or a residential unit, 150 to a 200 amp load center. And in some cases, especially in existing scenarios, that may be as small as 60 to 100 amps. Now, depending on what services are in an apartment, maybe there's no central washer and dryer, maybe you know, you can find a way to make the HVAC a separate service. There are some ways around this. But in a lot of cases, you're going to need to upgrade that load center and maybe even the additional, the main service to the building. So this can be a little bit of a challenge. And I think this is where that idea of really planning out and identifying when to make that upgrade. You know, you can probably swap out or add one device into the load center as it is existing, but you'd have to upgrade it if there more were needed. So there, again, that goes into kind of the planning piece of it. And then the next step really comes back to the resilience. And on the next slide, we look at the idea of grid capacity, which is a question that also came up, is, you know, and IIT has been on the forefront of this. I was lucky enough to be working at IIT and project managing the smart grid project there when it went into place. And everybody understood then that, you know, we're not going to be able to survive and electrify with the grid as it is. You know, there is going to be some efficiency gained through better design, through passive systems going into place, and through, you know, load reductions. But there's only so much load reduction that can happen in the existing building stock without replacing it. And so the grid does need to increase capacity, but it also needs to get smarter, because, you know, you don't need to double the capacity to bring on these services. You just need to make sure that the loads within them are managed well, and that the grid is managed well. And this is where the idea of microgrids and nanogrids comes in, is the idea of really placing some of the resiliency at the building level. And where that can't work 100%, then you add it to the microgrid level. And then the microgrid level feeds up into the grid level. And so there's a lot of different ways of accomplishing this resiliency and making the grid that much stronger. I think the idea of the grid, you know, being able to be down for a couple of days because the loads associated with it were, you know, keeping food cool and air conditioning and lighting, and people could figure out ways around those. You know, it wasn't this idea of the life safety of heating. But the grid can get more resilient. The grid can get stronger. The grid can fail as infrequently as the natural gas grid does if the right design and right modifications are made. And so I think that's where the Brownsville microgrid project and other microgrid improvements that are happening across the electric grid are really key and important. But if we go on to the next slide, one of the most important things, and I can't drive it home enough, and every single one of us has mentioned it, is this idea of equity. And I'm going to talk about equity really from the pollution side of it. You know, even if we tried to extend natural gas and keep it as a piece of what's going on, we have the internal issues, but we also have external issues. And we just went through this great transition where, you know, the two coal-fired power plants in the city, Fisk and Crawford, were decommissioned and are no longer, you know, polluting directly into the Pilsen and Little Village neighborhoods and all the communities that are downwind and upwind, or downwind of it, and, you know, in the various directions. But that's a great starting point, but it's not enough. If you go on to the next slide, we still have transportation that needs to be electrified. And again, dense urban areas are where a lot of people with at-risk communities are living, and there's still a lot of transportation going through them that is providing pollution directly into those neighborhoods. And at the same time, you know, the natural gas burning boilers and hot water heaters and that is still going into those areas as well. And so these are still major sources of pollution that are especially prevalent in densely occupied areas, which is where people in low income and at-risk communities are. And so the transitioning of this is really key, and it does have to start here because as Samantha pointed out and as Connor mentioned, this is just going to keep shifting costs further and further onto those who have not shifted over, because people with means will be able to make this happen much more quickly if the effort and the policies aren't put in that position. So just kind of to close it out on the last slide, the 3 things that you can do most immediately, really plan for yourself in terms of, if you're a homeowner, or if you're a situation where you're a condo association or have an ability to do this for yourself, plan it out, really figure out how this is going to happen and see that through and forward. Advocate. This requires looking at advocating for interconnection with the utilities, for things like CEJA, the Clean Energy Jobs Act, and the improvements there to make sure that electrification and renewable energy and other things can get put into place and that grid updates happen. And then lastly is really prioritize, which is, prioritize for yourself, but also make sure that these strategies and these technologies are implemented equally across the board so that the right communities and the right impacts are realized as quickly as possible. And with that, I'll turn it back to Margaret so we can go through the Q&A.
Thanks, Joe, so much. Yeah, and I'll invite our other panelists to come back on. And I think, Joe, we'll stay with you, or maybe Samantha, I don't know if you'd want to answer this one, because there was a question in the chat about kind of these grid infrastructure updates. Maybe we'll stay on that topic for a minute. But I think our questioner is really asking who pays. So how do we ensure that those costs, right? These microgrids and nanogrids are amazing technology, but they don't come without significant costs. So how do we ensure that that's not, regressive or passed on to people who can't afford that? I don't know who wants to take that, maybe Joe or Samantha?
I can start off, and I think Samantha can come in on some of the policy impact of it. So from a technical point of view, the grid is already being updated regularly, just again, from failure. So just like parts and pieces fail in your households and those have to be fixed. So there's already money set aside within utilities for these upgrades. So the next piece is making sure that money and advocating that money is spent smartly to do the smart grid updates and not just to do straight one-to-one replacements. Where additional infrastructure is needed, that's where really things like franchise agreement from the city, where entities have large leverage over a utility to really say, look, we're going to be adding, we're going to be developing and adding these many new customers. When these new customers come on, they're going to require grid updates. So some of that will be passed on to the construction costs of those projects, as it would anyway. But let's also make sure that some of that money goes into sharing the wealth and making sure that the grid around those new projects is coming into play. So there's a certain amount of making sure that money that's already set aside to improve the grid is spent smartly. And then this, I'll pass over to Samantha. This is where now the policy end comes. How can cities and states and municipalities help to make it easier for utilities or push utilities in that direction?
Mm-hmm. Yeah, just adding to that, and I agree with all that. Planning is so key. There's a concept that's being included in the Clean Energy Jobs Act called Integrated Distribution System Planning, that is looking to really change the way that we think about these costs in the distribution system and these upgrades that may or may not be needed with electrification, and to iterate on them more and to put them into a better planning process so that we can actually figure out whether there are alternatives to always adding new parts of the grid or making those capital investments in the grid. For example, rate design alternatives that we were just talking about throughout the panel. Are there non-wires alternatives we could be investing in parts of the distribution system to address load growth, either from electrification or other things? Maybe it's a new customer coming online in a particular geographic part of the distribution system, and really looking in those key areas and making sure that we are addressing lower cost alternatives, which could include, it could include a microgrid, it could include a battery, right? It doesn't have to always be investment in costly distribution system upgrades. So I just want to mention that's a really key part. And then more generally speaking, rate design, if we can capture this flexible demand, all these appliances behind the meter that are largely controllable, and this also includes electric vehicles too. If we can align this with rate design and send the right signals to customers and automate a lot of this, then we can actually charge and use these appliances at times when the grid is cheaper. And we can also integrate with renewables. So when wind is high on the system and normally would be producing so much that it's curtailed, we can actually be, preheating our water heaters, for example, or pre-charging our EVs. And so those are ways to better utilize the grid such that electrification and all this new load ends up being more of an opportunity, right, than a detriment. And then, of course, there's always those rate cases that we welcome municipalities to come intervene in at the ICC and, make your arguments for why we should be spreading these costs out in a more equitable way.
Thanks. Yeah, I think it underscores that we have many of the pieces of the puzzle. It's all about kind of integrating them, making them work together. Connor, I wanted to throw you this question in the chat. It's specifically about, I think, refrigerants and how those are taken into account when you think about embodied carbon in new construction.
Yeah, that's a really good question. So if we're thinking about how our buildings are conventionally heated and cooled, right? We typically have some refrigeration source already, right? Whether that be as simple as a window AC unit or going back to, your conventional DX cooling type of equipment. And when you're looking at a heat pump system, that heat pump system really doesn't differ in the refrigerant charge for an air source heat pump to that conventional DX refrigeration system providing cooling in let's say, your furnace system in your house. The only additional add that we have is going to be coming on with the heat pump water heaters. And that charge is typically less than a conventional air conditioning charge. It is really important to consider the global warming potential of that added charge as that leaks. It's leaking refrigerants like 1,000 times greater global warming potential than CO2 in itself. So there's some things to make sure that you're actually going through the process to recycle that refrigerant, dispose of that properly, as well as there's some CO2-based refrigerant technologies out there specifically designed for hot water heating. So one of the manufacturers, I believe, is called Sandin. They're getting some traction here in the US, which is really great. But when everything balances out across, what you have is like the methane leaking from your conventional natural gas systems with that little bit of additional add of refrigerant from the hot water heaters, you're still tipping the scales to the positive when you electrify, even adding in that global warming potential. So it's a really good question. It's something you should certainly be thinking about and think about what do you do with the end use of that equipment. So it's actually a really good idea if your refrigeration or your not your refrigeration, but your AC system is kind of towards the end of life, to consider actually replacing that with a heat pump system. And so making sure that is properly disposed of is really good practice.
Thanks,
Margaret,
Connor.
if I can just jump in really quickly, I think it's the simple answer to the question is, as Connor said, yes, it needs to be considered. One of the things we always issue caution about is, it's easy to take things like that to an extreme. I'll share just a little bit of a case in point. We were working with a district plant operator, and there was a conversation about the global warming potential of refrigerant in the plant and leakage and things like that. And someone was suggesting, oh, well, the leakage should be this much or that much. And the plant operator responded, if I did that, I wouldn't be so worried about the environment as much as I would be worried about going to jail, because it's illegal to put that much refrigerant into the environment. So I think it's always good to be cautious about things like this, but realize that, well-installed, well-designed, well-operated systems are not leaking, the entire volume of their refrigerant in there, and to be smart about looking at those leakage rates. Now, because a lot of these systems are not factory built and are, built in the field, that's where going back and using qualified contractors, making sure that designs are right, making sure that the system setups are so that, refrigerant leak detection is in place and the like. There are a whole bunch of ways to solve that, but it's also being smart about not overplaying the hand of how much refrigerant will get lost.
Thanks. Well, I think we're about at time. I think Katie's going to wrap us up. I just wanted to say thank you to our panelists and everyone for joining. And Katie, do you want to have the final word?
Yes, thank you so much. Sorry I had to pop on. I know that we were going to run out of time with this awesome discussion. So Thank you everyone for sharing all of your thoughts and your expertise today. I did copy down all of the questions that we missed from the chat and the Q&A. So we'll get those back to our panelists and share that all in a follow-up email along with a lot of the links that were shared as well. So thank you all again for joining. This won't be the last conversation we have on this topic for sure. So if you have other thoughts about education programs Illinois Green should offer moving forward into 2021, please do email Margaret or myself, reply to the follow-up note with some things that you'd like to learn in the coming year around this topic. So thank you again, everyone, for joining. And I'm going to leave it with one last takeaway that everyone should do when they get off this webinar. Less than a sentence from each of you. I'm going to start with Joseph Clair.
I got the luck of doing that in my presentation, so I'm just going to say, plan ahead. If there's one thing you do, look at your electric panel. Look at that and what you got in there, and spare circuits. And if you don't have enough there, talk to someone, engage a friend, an electrical engineer, and kind of talk about what's the next thing you need to do, and put that on your plan in your budget, and see where it goes from there.
Perfect. Connor, you're up.
All right. Especially for new construction, go all in, cut your gas connection. It's the best pathway forward.
Perfect. Sam.
Demonstration projects, do as many as we can, but can I also plug those 2 reports I mentioned earlier? In addition, the Green Lining report on equity and the Rewiring America report, which will really, I think, bring about a lot of excitement about this opportunity with electrification, and again, the economic juggernaut that this could be for our country.
Perfect. Margaret, you get the last word.
Email me and Katie about the things that we didn't answer, the things that you still want to learn about, and we will talk to you about it in 2021.
Perfect. Thanks, everybody. Have a great rest of your afternoon.